All right, it's 7 o'clock. Let's go ahead and get started. If folks arrive late, what can I catch them up as needed? So this is our free class on Intro to Python, and I'm Erik Gross. I am a senior level software developer, got decades of experience coding. I'm also a U.S. Navy veteran. I was a nuclear reactor operator, electronics technician, and also a classroom instructor in the Navy, which I got volunteered for and turned out to change my life. I just absolutely love training, education, the whole learning experience. I'm also the co-founder of the Tech Academy, the organization that puts on these free classes, and I'm really happy to be here. So a couple basic guidelines for the class. We have an assistant in the class. You'll notice Gracie from time to time pop in and out. And her role is to monitor the chat, answer questions. Please be nice in these classes. Otherwise, Gracie will remove you. It hasn't happened in about a year, so I'm not too worried about it. I do want to point out that while these are introductory coding classes, the students may run into challenges, and part of the learning process is working through those challenges. So just use chat as needed. I try to monitor it all the way through, and so does Gracie. Again, it is introductory. You should do fine. One thing to stress is that you should be sure to type the code that we write. In a little while, we'll be writing code. You should be sure to type it exactly as it's written. And the reason why is that a misspelled word or a missing symbol or even something capitalized, it shouldn't be capitalized, can result in errors in your code. Another thing I want to cover is the distraction-free environment. Please make sure you're in a distraction-free environment and you can focus on the class so I don't lose you. I like to help people get as much as possible out of these classes. With that said, if you get lost or you can't keep up with the coding, don't worry about it. Stick around and pay close attention because you'll still learn a lot, even if you don't end up being able to type out every little bit of code that we go over. Very often we have questions about whether these are recorded and if people can have access to the recordings, and the answer is yes and yes. This will be up on our free YouTube channel within about 24 hours. Also, you'll get a full copy of all of the code for the game that we're going to show you at the end. You'll be able to play the game. You'll be able to tweak the code and mess around with it if you want to. You'll get the full code. We're also going to provide you with links to our future events, our free videos, and other resources at the end of the event. I don't need to say much about chat. You're all really comfortable using chat. I do try, like I said, I try to watch it all the way through. There's also a Q&A period after the coding to be able to catch any questions we didn't take up during the actual coding. So here's the basic agenda. We'll have a short explanation of the Tech Academy, who and what we are, and then we'll write code. There is a brief Q&A session, like I mentioned, although I do try to answer questions during the coding. Then when we're done with that, we'll cover some information about our boot camps, how we help people get into the technology industry. And there's a free gift for you at the end, so stick around until then. Whole class should take about an hour to an hour and a half. So who are we? Well, we're the Tech Academy, and we're a technology training company. We deliver coding boot camps. If you're not familiar with coding boot camps, they are intensive technology certification programs, and they're designed to prepare people for entry-level positions. What's really wild about boot camps is that they typically only last 3 to 6 months. They focus on modern practical skills, which means you can break into tech very quickly. Now, at the Tech Academy, we've been offering thorough, budget-friendly, flexible, and trusted coding boot camps for over a decade now. We were around at the beginning of this industry. Our certification programs are very cost-effective. They're self-paced, they're fully online, and they're tailored for beginners, people with no prior technical or coding knowledge. They cover in-demand skills for the tech industry. They're endorsed by stellar online reviews, and they're designed to fit around your personal schedule. And we work to prepare you for your technology career with a really well-rounded toolkit. Nationwide in America, the average cost of boot camps is around $13,500. Our boot camps are well under the national average. In fact, we have boot camps that start as low as $59.80. And I always like to wrap this part up by just giving you our mission statement. The mission statement of the Tech Academy is to graduate entry-level technology professionals that excel in the basics of their field and thereafter have successful careers in the tech industry and whose actions raise industry standards and surpass client expectations. Our product is you working in tech. All right, so let's cover a few fundamental terms before we jump into coding. And the first one is just the word program. A program is just a series of written instructions that you can enter into a computer to make the computer do things, make it perform specific tasks. It might open up a file. It might provide a window where you can type text in. It might show the controls of a game on the screen. That's a program, right? It's the instructions you enter into the computer. And those instructions are written in what's called a programming language, which is a well-organized system of words, phrases, and symbols that is how you communicate with the computer, how you tell it what to do. Programming languages are what we use to create computer programs. And then there's the verb coding. Coding is just the action of putting those instructions into the computer. When you're sitting there typing in all these instructions and figuring out in your mind how the program's going to work, that's called coding. And the instructions themselves are called code. So the last thing I want to cover in terms of fundamental definitions is Python, because that's the language we're going to use to teach you some fundamentals tonight. Python is extremely popular. It's been around for about 35 years. And it's very versatile. It's really good for a learner who is new to coding because it's very approachable, but it's also very powerful, and you can create a whole wide variety of different types of computer programs with it, from video games to mobile apps or web applications, websites. All kinds of programs can be written in Python, which is another reason why it's good to learn in terms of having a bunch of powerful technologies in your tool belt as a software developer. All right, now, before we get into coding, we're actually going to teach you one of the most important, most fundamental things about computer programming that you'll probably ever encounter. And it's going to seem quite simple. But in my experience, not having this key information that we're about to lay out can really make the coding journey or the learning journey very, very difficult. But with this information, it can stabilize you. It can give you a solid foundation. So what we're going to cover is, what are the 5 fundamental elements of any computer program? No matter how simple or how complex, every program is made up of these 5 things you're going to learn about, and only these 5 things. So they're sort of important. Let's start with the first basic element of a program, which is the entrance point. There's nothing super complex about this. This is just the very first instruction. Excuse me, the very first instruction in a program. Now, this is actually important for 2 different reasons. The first reason has to do with your computer. When you run a program, it's being run on a computer. I mean, it's pretty straightforward, right? But what you may not know yet is that when you start a computer program running on your computer, a number of things have to happen under the hood with that computer to make it possible for your program to run effectively. One of the most important things is this. The moment you start a computer program, the computer that it's being run on will do something really, really important. And it has to do with where your program can store the data that it's going to work with. Programs work with data all the time. It can be number data, it can be text data. The programs work with data all the time, and you got to put that data somewhere. Now, as to the somewhere, inside your computer, there's my computer, my tower on my desk. Inside your computer are little devices where you can store data. They're called memory devices. And when you start up your computer program, what the computer does is it goes into those memory devices and it blocks off a section of the places where you can store data, these memory locations. It blocks some of them off and says, hey, these are reserved. These are reserved for this program that just started up. And in that way, no other program can interfere with that data storage area. It keeps the data that your program is going to work with safe. And it's actually really important. However, it does mean that that's that much less storage area available for the other programs on your computer. So that's one of the reasons why this entrance point is pretty important. As soon as that first instruction starts, your computer reserves some of that storage area. Now, you don't see that happening. Let's talk about something that can help you as the developer, things that you can see. Knowing that there's a first instruction in a program, the first point where meaningful work happens, can really help you as a computer programmer. And here's why. When you inherit a computer program, like you didn't build it yourself, but you joined a team and they're responsible for maintaining a big computer program and adding new features onto it and fixing bugs. When you find yourself in that situation, it can be kind of overwhelming to try to get familiar with that program. These programs can sometimes contain, thousands of files and tens or even hundreds of thousands of lines of instructions in them. And it frankly can be overwhelming. But what can stabilize you and help you to understand that program is just this simple knowledge that somewhere in there, somewhere in that program is the first instruction, the first point where work occurs. And it's actually relatively easy to find that in any given program. You can find that first spot where work gets done. And that's really valuable because that's where you start looking at the code and tracing along to see what the program does. You don't start at random with one particular function or area that you find interesting. You start right at the beginning and just look at what that program does from the moment it gets turned on until it's up and running. So this entrance point is actually pretty important. Here's the second element of any computer program that's pretty important. It's called a variable. Now, do me a favor, drop into chat, and if you are familiar with what a variable is, can you give me an explanation for a variable in your own words? Drop that into chat. It goes straight to me. It's not shared with everybody. I'd like to see if you can explain what a variable is. And if you're not familiar, it's totally fine. I'll give it a minute for anybody to type, and then we'll move on. Oh, I like that. Data that has multiple functions or uses, dependent or independent, kind of like a placeholder. I like all of these explanations. Something whose value is defined in the program. These are all very, very good. Good. Here's the thing. Before we move a step farther, I want to talk to you about what the purpose of a computer is. Do you ever stop to think about that? Like, what's the purpose of these things? I mean, most machines that mankind has made have a purpose. Otherwise, they wouldn't be created. You can create a vehicle. Its purpose is to transport people or things. That's a vehicle, right? Purpose of a comb is to style your hair, unless you're bald, and then it has no purpose. Computers are no different. They have a purpose. Here's the purpose of a computer: to take in data, to process that data in some way, and to send data on. That's actually the purpose of a computer. At its most bottom, like rock bottom, its most fundamental purpose is to take in data, process the data in some way, and then send the data on. And so data is pretty important. Well, while a program is running and it's working with data, very often that data can change. If the data that you're keeping track of is the total amount of a certain product in the company's inventory system, obviously that can change as sales happen, as new deliveries are registered into the warehouse. That data can change, right? Without the ability to keep track of data that can change as the program is being run, programs aren't very valuable to mankind. And so one of the fundamental elements of any program is variables. All right, and by the way, you're going to build most of these things in your own code tonight. Let's move on to another really vital, well, these are all vital. There's only 5 things that every computer program is made up of. They're all going to be vital, so I'll stop telling you they're all important. So the next fundamental element of a computer program is control and branching systems. Now, it sounds all fancy. All this is a way to make it so your program can make a decision. It's the simple if this, then that sort of concept. And we all do this all the time. We all make decisions all the time as human beings. But remember that we're using these computers to automatically handle data the way we would if we were doing it ourselves. And since we have to make decisions all the time surrounding data, we have to have that inside of a program. How do we tell a computer program to make a decision? And this is, again, something that you're going to code tonight. You're going to write this into a program. And it's one of the more fun things to do is get to figure out, how do I articulate to a computer, a machine that can't think? How do I articulate to a computer the exact decision that it has to make? And more importantly, what to do based on the decision it made. And you'll see that play out tonight. But I hope you can see that that's a fundamental element of any computer program, is building something into the program that enables the program to make a decision based on data. All right. The next fundamental element of any computer program is something we call subprograms. As you can see on the slide, you can consider them programs within programs, which sounds very much like the Leonardo DiCaprio movie Inception, but it's not so frightening. Here's all we mean by programs within programs. If you can think of a program almost as a recipe, an exact series of instructions that you're going to go through one after the other, try to get this idea. Let's say you're building a very long program. It's a big program. And over again, throughout all these series of instructions, you're finding that there's a certain series of instructions that are the same exact steps every time, and you're doing that at many different points in your program. You're repeating these same 4 or 5 or 6 instructions, perfectly identical, every single time you need that exact thing to occur. This happens more often than you'd think when you're building a program. Programs are great for repetitive tasks, right? And when you repeat a task, you want it to be done the same way every time. Well, rather than typing out that exact series of instructions every single time you need them to happen in a program, why not take that set of instructions and put them off to the side, almost like in a little box, and put a name on the outside of the box? This is called subprogram number 1. And inside are the exact instructions you want done. And that's essentially what you do with a subprogram. And now what's cool is when you're making your program, one instruction after the other, and all of a sudden you find yourself needing those instructions that are in the box. Instead of writing them all out, you can just say, hey, go do what's in the box. Go do what's in that subprogram number 1. And when you're done, come back and pick up where you left off. That's the concept of a subprogram. And they're very, very powerful. And again, you're going to build one of those tonight and see what it looks like in real code. And finally, the last fundamental element of any computer program is an exit point. A way for your program to tell the computer, I'm done. This program has stopped running. Now that's important for a number of things, and you learn a bunch of nerdy detail about why on our boot camps. But one of the more important ones I can tell you right now, because we covered it on the entrance point, and that is, if when we started up our program, that signaled the computer to reserve some of that data storage area in the storage devices, when you turn off the program, when the program is done, now the computer can release that storage area and say, hey, this is no longer being reserved. It's available for other programs to use now. And so there you have it on this screen. These are the only things that are ever inside any computer program, period. End of story. Now, they're not always in this exact order. The only ones that are in the exact right order are numbers 1 and 5. But in between there, with variables, control and branching systems, and subprograms, you just put them where you need to accomplish the program's purpose. And again, you'll see some of that tonight. All right, so there we are, the 5 elements of a program. Now let's get to coding. In order to write our code, we need a place to type or edit our code. We need a code editor. It's just like writing any other document. You need a window where you can type in the code. You also need a window where when you run the code, you can see what its output is. You can see, remember, computers take in data, they process the data, and they send it on. we're going to send data on to a little window where we can see some output. We do that in a special little online code editor. And Gracie, can you drop that link if you haven't? Yeah, there it is. So look in chat, and you'll see a link that says bit.ly Tech Academy Python. Click on that link, and you're going to see something that looks like this on the right. Now, before you do anything, don't worry about any of the code that's already there. There's a little housekeeping thing I want to take care of. I'd like you all to be set up so that your code editor that you just opened, that's your code editor, you get to use it tonight. I'd like you to set it up so that code editor is on the right side of your screen, and I am on the left. Now, if you've got two monitors, don't worry about that. Put the code editor on one monitor and put me on the other monitor. But if you've only got one monitor, then split it and put me on the right. Sorry, your code editor on the right and me on the left. Now, how do you do that? You have to resize the program that I'm in. I'm in the Zoom program for you, right? So to resize Zoom, sometimes it doesn't like to resize easily. You can click on the word Zoom meeting, and this little restore button will come up. If you click on that, you can resize your Zoom window and move it around to where you want. The same thing sort of exists with your web browser, because your code editor is in the web browser, probably Chrome, if you're being smart. And with the web browser, you can click on this little symbol up here that looks like two little squares, and you can resize your web browser. So I'm going to give you all a moment to get set up with your code editor on the right and then me on the left. All right, so let's talk about coding. We're going to build a Connect 4 game. Well, we're going to work on some of the fundamentals of it. We're not going to build out the whole game because that would take 3 or 4 hours, and you'd all want to go to sleep by the end of it. Okay, but we're going to be working with this idea of a code, of a Connect 4 game. So the first thing I'm going to do is I'm going to show you that code, that game in action. So here's the code editor. I'm going to get rid of all that code. Don't worry about any of that code. And I'm pasting in the code. And we're going to look at all this code later on in the class. Don't worry about any of this right now. This is the code for our Connect 4. So you can see the Connect 4 grid over here. And I am player X, and I'm going to choose, am I going to drop a Connect 4 piece in column 1, 2, 3, 4, 5. So I'm going to put it in 3. And so mine went down into 3, and the computer put one in 2. So I'm going to put one in 4 right now. All right. I'm going to put one in 5 right now. Let's see if I can win this game. I think I'm going to win the game. It's not a very intelligent programmer. I'm sorry, opponent. So that's the game, okay? And I am going to not play the game again. All right. So for right now, we're going to revisit this code in a while. Okay. What I want you to do is I want you to clear out all the code that's in your editor right now. Okay. So you got an empty screen, and then we're going to start building some actual basic computer programs here. Now, I want to stress before we write a single line of code that on the surface of it, some of the code we're going to write might seem very simple. If you've already done some study of computer programming and such, it may seem like very simple examples. But we do this for a reason. Learning the fundamental principles behind computer programming is one of the most important things you can apply yourself towards. And some of the fundamentals are best communicated with very simple code. So let's do a simple piece of code. We want something to print over on the right-hand side here in the output window. So we're going to use a command called print, P-R-I-N-T. Although it's a question I missed that says, what's the correlation between web browser and intelligence? Nothing. If I said something like that, I apologize. I confused you. Okay. Let's grab the link again. There's the link to the code editor. Okay, good. Oh, we got it a couple of times. All right, so type in print. That is a Python instruction. In other words, when we talk about a programming language being a system of words, phrases, and symbols, this is one of the words. Print is one of the words in the Python language. Now, it changed color just because this code editor has what's called syntax highlighting. That means it will change the color of some of the text just to help you know at a glance what the importance of that text is. It doesn't change how the program works at all. It just makes it a little easier to read. So here's the next thing you do is you want an open and close parentheses. So give me an open and close parentheses. This code editor will automatically fill in the closed parentheses for you. It's just a nice feature. And then inside there, do a double quote. It's just to the left of your enter key. Do a double quote. And put my name is, and then type your name. And when you're done, just click on this play symbol up here, this little triangle, and that's to run your program. And you should get my name is, and then whatever your name is over on the right-hand side. All right, again, it's a pretty straightforward instruction, but there's a couple of really valuable lessons to learn here. The first one is sort of a high-level thing. Print is an instruction. It's an instruction built into the Python language. Lots of instructions, in order to be able to do their job, need some information to work with. Not all instructions will, but many instructions will need some information to work with. In this case, the print instruction needs the information of, what do you want me to print on the screen? Now, I bring this up because the way to provide information to an instruction is to put it inside of parentheses. And more importantly, immediately following the instruction. You don't do a space. You go immediately following the instruction. This is a pattern that's used in lots of different programming languages. And then, of course, inside the instructions is the information that you want printed. Now, why are there quotes on either end of it? Because we want text information to be printed on the screen. And in the Python language, to designate information as text, you put double quotes on either side of it. So that's some high-level stuff. Now we're about to get really, really nerdy, but it's actually really important. I'm going to show you how to think like a computer. All of us looking at this instruction can figure out that we're going to print something to the screen because we see the word print. But I'd like to point out the computers can't read. Even more precisely, computers can only ever do one thing at a time, and they can only do what they've been told to in advance. They can't decide things or figure it out for themselves. Computers are not just stupid, they're just robotic. Now, what does this have to do with thinking like a computer? I want to step through with you one step at a time how the computer will actually perform this line. I'm putting my cursor all the way at the back, at the beginning of the line. And I want you all, please, to follow along very closely. We're going to go through this slowly because it's actually really important. When the computer is about to run the next line of code, and this is the next line of code, it's the first one, right? When the computer is about to run a line of code, what it does is it actually starts at the beginning of the line and it just reads the first character. And what it does then is it checks whether that character is one of two different things. Is that character a built-in instruction in Python? Maybe the letter P happens to be a built-in instruction in Python. Now, it's not. And we'll cover that in a second. But the second thing that the computer checks is, okay, well, the letter P is not a built-in instruction in Python because I have a list of them installed on the computer. Well, is the letter P a variable? We talked about variables earlier. Is the letter P a variable? And it isn't. We haven't made any variables yet at all. So it goes, oh, it's not an instruction. It's not a variable. Fine, I'm not going to do anything. I'm going to read two characters. And now it has the letters PR. So it does the same thing. It goes, is PR a built-in Python instruction? No, it's not. I have installed on the computer a list of all the Python instructions, and I checked, and PR is not a Python instruction. Okay. Is it a variable? Again, no, we don't have any variables. And it will continue to do this with the third character. Is PRI an instruction? Is it a variable? With the fourth character, is PRIN an instruction? Is it a variable? No. PRINT. Is PRINT an instruction? Yes. It's programmed on the computer. I installed Python on this computer, and I looked, and there it is, print. Okay, good. What's supposed to come next? Well, in the Python language, it says the next thing you're going to encounter is a parentheses. So it goes, oh, look, there's a parentheses. Okay, good. And in the Python language, it says that you're going to find a matching end parentheses. And so it will actually read all the way forward. It just keeps on going. Nope, no end parentheses, no end parentheses, no end parentheses. Oh, there's the end parentheses. Okay, good. And now it will say, the Python language goes, inside the parentheses is the information I need to print on the screen. And so it'll go to the beginning. It'll go, all right, well, what's the first thing I encountered? Oh, it's a double quote. And the Python language knows if the information that the print statement is going to use starts with a double quote, then there's got to be a matching double quote at the end. So it goes and it finds it. It goes, oh, okay, everything in between these two double quotes is the information I need. And so it grabs all that information. And only then, after it's done all of that, does it print it out to the screen. Now, that took me a few minutes to describe. In a computer, it takes it about 1 or 2 milliseconds to actually do all of that. Computers are very fast. But the reason I went through all of that is to illustrate something about a computer. It can only do what it's been told to, what it's been pre-programmed to do, and it only does one thing at a time, and it operates on patterns. The letters PRINT are an exact pattern, and the computer can match that pattern against a pattern that's been programmed into it as, quote unquote, this is the Python language. The computer doesn't understand that that's a word, and that that word is print, and that that means to put something on the screen. It doesn't understand that at all. In fact, computers don't understand anything. They only operate on patterns, and they only do what they're told to. Now, thankfully, for the pattern PRINT, that matches a Python instruction. And thankfully, that instruction was programmed so well that the computer now knows exactly what to do. So, again, it's one line of code, but there's some real fundamentals at work there. All right, let's move on and do something a little bit different. Let's use a variable. We mentioned variables. Variables, again, are ways to keep track of information that can change while the computer program is running. Variables are best thought of before we get to the actual specifics of how they're handled inside a computer, let's talk about them conceptually. The best way I've found to think of a variable is this. You have a bucket, and inside that bucket is where you're going to put information. Specifically, it's information that could change as the computer program runs. But on the outside of that bucket, you're going to put a name, a unique name that identifies that bucket and only that bucket. That's the best way to think of a variable. Let's write the code to make a variable. To do that in Python, you just come up with a name for the variable. We're going to call it matches. In other words, how matches in my mind means how many of your Connect 4 colored pieces are in a row. Is it 1 or 2 or 3 or 4? And if it's 4, then you win, right? So that's matches. That's the name of the variable. Now, at this point, using our kind of interesting example or metaphor, all we've done is we put a name on the outside of our bucket. We have not yet put any information in the bucket. To do that in Python, you hit a space and then you do this symbol. It's the equals symbol. Then you hit a space, and now you put down what information do you want to store in the variable. Let's say it's 3. Notice we have 3 matching pieces. This is how you make a variable. Now, there's actually 2 things happening on this line. And I found it's kind of important to understand the 2 separate things that are happening here. And I'm going to teach you the specific terminology in the programming world. The first thing that's happening is we're creating a variable. All we do is put the name out there. And that means we've made the variable. The computer term for this is we are declaring the variable. Declare. You declare a variable. Now, the second thing we're doing with these lines, this part of the line, is we are putting data into the variable. That's called assigning a value to the variable. So we declare the variable, and then we assign a value to the variable. That tells you that this symbol is a symbol that means assign a value. And here is the value. So those are the parts of this line of code: declaring the variable and assigning a value to the variable. So let's use this. Let's print to the screen how many matching pieces we have. So you do print, and then watch this. We do number, make sure you do your double quotes, number of connecting pieces, colon, and then hit a space. Now I'm going to give you all a moment to catch up. Remember to type it exactly, well, remember to type it exactly as I have. All right, now, we're going to use this variable. We have a variable called matches. That's the number of connecting pieces we have. There's 3 that connect, okay? So what we're going to do is kind of cool. We're going to print off everything inside the double quotes. We're going to print all this off. And right after that, we're going to print out the value inside the variable called matches. And you do that, go to where my cursor is, right after the second double quote, and hit space, the plus sign, and then the name of your variable, matches. And when you're done, run it, and then we'll talk about this a little bit. I made a mistake. Actually, I remember doing this on purpose. Let me explain what's going on, okay? So Before I explain this, can anybody tell me why we threw an error? Any ideas about why there's a problem here? Let me look at the chat. Robert, you're absolutely right. But you're also a Tech Academy graduate, so I know you know all this stuff. Maybe because there's nothing after the colon. Ah, okay. So this is Jonathan. Jonathan nailed it. You are trying to join a string with something that is not. So let's explore this for a moment. Remember my really laborious, detailed explanation of how the computer performed this line of code? My explanation that went on for minutes too long. And what I said was, the way the print instruction works is that everything inside the parentheses, this is important, is the text information to display on the screen. Text information. Now, here's the problem. There are different types of information that computer programs work with. They can work with text information, but they can also work with numerical information. And as Jonathan said, on line 3, this symbol right here isn't math. This is not a math symbol. This is a symbol for take two pieces of text and join them together. The actual nerdy term for that is concatenation. We are going to concatenate two pieces of text. The only problem is this is a piece of text. This is not a piece of text. This is a variable, and the value inside the variable is not text information, it's number information. So you can't add text plus a number. Sorry, you can't concatenate. You can't concatenate. You can't put together or connect up text information with number information. It doesn't actually make sense, does it? So what do we want to do? We actually want the number 3 that's stored in this variable. We want to turn it into text information. Luckily, Python has a way to do that. What you do is you have a special built-in instruction it's called str. You do str, and then you put parentheses and go to the end here and put another parentheses after matches. I might have to do it twice. We turn that number 3 into the text character 3. And now run this. And notice it works. Why? Because that's not actually the number 3 that's being displayed on the screen. It's the symbol 3 in text form. Now, I know that seems really wild because to us as a human being, we can go, Eric, that is clearly the number 3. Your computer can't read. The computer can't take a look at this variable called matches, which has a value that's a number, and go, well, I know you were trying to print out the character 3. I know what you meant. Computers don't do, I know what you meant. They just do what you told them to do. And what we told them to do, by the way, I'm going to do a Control Z. Don't do the Control Z. I'm just going to revert for a second. What we were trying to tell it to do right now is we're trying to say, hey, you know the number 3 that's stored in this variable? You and I both know that I actually don't want the number. I want the character 3. It's not a math thing. You and I both know that, right? The computer doesn't know that at all. And this all has to do with the concept in a computer program of data types. What type of data is being stored? What type of data is being worked with? And this stuff is important. So we're working with number data. and we are going to turn it into string or text data. Strings, str, strings are just text data, like this is a string. All right, any questions about that? I'm going to watch chat. Anybody have any questions about that? Jonathan, you nailed that. That was great. All right, so why do we care about all this? Well, guess what? What if all of a sudden someone gets another connect? Let's make our variable matches, and let's make it equal to 4. And now let's do the same thing. Let's print number of connecting pieces, colon, space. It's the exact same line of code as above. Plus, turn it into a string, in parentheses, matches. Same exact line of code. Don't copy and paste it, by the way. Take the time to type it out. When you run this, I know it seems so straightforward because you can read it. I spent my time explaining it, but there's actually something really cool going on here. We are keeping track of data as it changes, and we're using the current value of the data in our program. At the point in which we execute this line of code, the value of the variable matches is 3. But at the time we execute this line of code, the value of the variable matches has changed, and our program reflects that. So this is variables. All right, now let's move on to control and branching. This is fun. What happens if someone has 4 matching connections? They win the game, right? But what happens if after you take your turn, you don't have 4 matching connections? That means it's the other person's turn. This is a decision that we're going to make over and over and over again in our program. Every single time someone takes a turn, we've got to figure out how many matches there are, how many connecting matches, and we have to decide, did they win the game or is the game still going on? That means we need to be able to tell our computer to make a decision, whether to end the game because someone won or to continue the game because nobody has won. We need control and branching. One of those 5 things we talked about at the beginning of the class. So how do you do this in Python? Well, you use a type of instruction called a control instruction. In Python, the most common control instruction is if. So type if, and then give me the double parentheses like that, or open and close parentheses. And clearly, we're going to put some information inside here that's going to be used by the instruction if. It's the same pattern we saw here on print. Inside the parentheses goes information to be used by the print instruction. Well, what kind of information gets used by an if instruction? I'll tell you what kind of information. True or false information. If something's true, then do one thing. Otherwise, do another thing. That's the logic involved here. More precisely, what goes inside these parentheses is a piece of code that can be evaluated by the computer, and the computer can figure out whether or not what's in there is true. It's going to compare some data and figure out whether that comparison results in true or false. Specifically, we want to know whether a number of matches, let's do matches, M-A-T-C-H-E-S, is equal to, do 2 equals 4. I'll explain all these symbols. Now, it's time for a new word. This symbol right here is called an operator. That's a kind of a symbol in Python. An operator tells the computer to do something. On line 2 that I have highlighted, what that symbol, this operator, does is it tells you to assign this value to that variable. This operator is called an assignment operator. I know it looks like an equals symbol, but we're not talking about math here at all. This symbol, as it's used in the Python language, is called an assignment operator. It says assign a value to a variable. Well, this symbol is also an operator, but it's not an assignment operator. It's not saying, and this is critical, it's one of the things I see get people messed up when they're first learning Python. This doesn't mean take the variable matches and make its value 4. It does not mean that. What it means is compare the value of this variable called matches to this number and see if they are equal. Compare them. So this operator is called a comparison operator. This operator is called an assignment operator. So what happens if matches does equal 4? If the value of the matches variable does equal 4? What it means is the computer says what's inside these parentheses is true. Now, what we need to do is decide on what happens then. We get to decide as the programmer, what do we want to do if this bit of code ends up being true? Well, the way you write this in Python is by writing what's called a code block, a block of code. It's a chunk of code. It's one or more instructions in code that it will only be performed if this condition is true. That's what we're going to make. So here's how you do it. Go to the very end of this line and hit colon, not semicolon, but colon. And then the next line underneath it needs to be indented over by 2 spaces. Now, if you hit enter, the code editor will indent it for you. The reason for this is underneath this line, if matches equals 4, underneath this, any instructions that are indented will only be performed if the condition is true. So what do we want to have happen? Well, we're just going to keep it simple. We're going to print you win, E-R-I-N-T, and then in double quotes, you win. You can put an exclamation point if you want. Now, tell me in chat, what's going to happen when we run this code? Don't run it. Guess in chat, what's going to happen when we run this code? It'll say everything we wrote after print. It'll say this one, it'll say this one. And will it print you win? All right, run it. And it says you win. Why? Because at the time we run line 7, the value of the variable called matches is 4. Now watch. Go to line 4 here and change the value of matches to 2. What's going to happen now? Put your guess in chat. The win won't run. That's exactly right, Nikkei or Nick. Run it. We get the first 3 things we expected. They're right here. We don't print out you win because the value of matches is 2. All right, good. So We know what to do when we win. We know what to do, or we've decided what to do if matches is equal to 4. What happens otherwise? We need something else. So remember, we're making a decision. Here's what to do if it's true. We now need to put down what to do if it's false. So go to the end of your final line of code there, hit enter, and this part's important. You have to backspace to the beginning of the line. Why? Because we're done writing down what to do if the condition's true. If we didn't indent, then we'd still be putting down things to do if the condition is true. And we're not anymore. What we're going to do now is provide the alternative. And the way you do that in Python is using a special instruction called else. And then a colon, and then hit enter. Now, the way this reads in plain English is, if this condition is true, then do these instructions. Otherwise, do these instructions. So when you hit enter, you should indent by 2 spaces, and now we're going to put down what to do if matches doesn't equal 4. And we're just going to print, print, keep playing. Like that. So now run your code, and lo and behold, it says keep playing. Why? Because matches did not equal 4. Matches equaled 2. So what you've got here is a control and branching system. The if and the else are control instructions. The branches, in other words, what you're going to do based on the decision, are the code blocks. This is a branch, and this is a branch. Now, we've kept them very simple just to illustrate the concept. But you could have any number of things that will happen if matches equals 4. And you have any number of things that will happen if matches doesn't equal 4. Again, we've kept it rather simple. All right, any questions on that before we add one more fun layer of complexity? Okay. So let me ask you this. How many times while someone's playing a game of Connect 4 do you think we're going to have to figure out whether or not the game is over? We're going to have to do it over and over and over and over again every single time someone takes a turn, right? Well, I don't know about you. If I'm building this program, I don't want to write out these instructions 25 or 30 times. That's very boring to me. Thank you very much. So what I want to do is I want to take these instructions and put them in a subprogram. And here's how you do that. Go to the bottom here, make sure you hit backspace, okay? And we're going to create a subprogram, a program within our program. Now, to be very clear, in Python, subprograms are called functions. In other languages, they're called methods. In other languages, they're called subroutines. And in other languages, they're called subprograms. It's all the same thing. A subprogram, or again, in the case of Python, a function, is a repeatable set of instructions that's given a name. The set of instructions is given a name, and you can call on those instructions to be performed whenever you want. That's what we're going to make. You do that with a special instruction called DEF. It stands for define. So type define and then hit space. The next thing you need to give Python is what's the name for this function, for this subprogram. We're going to call this check win. We're just going to see if someone won. Seems like a perfectly fine name for the function to me, because we're going to need to do this over and over and over again, right? So you type the name. Now, the next thing that's going to be needed is an open close parentheses, and we want to talk about why. We have this pattern in use already. After the instruction print, we've got open close parentheses. After the instruction if, we have open and close parentheses. This is a pattern you've seen a number of times already, but you've seen this pattern with the built-in instructions that Python comes with. When you make a function, you're making your own instructions, but they work the same way. Sometimes when you're building one of these functions, it needs information in order to do its job. And so the way the Python language works is when you're making a function, you have to put an open close parentheses right after the name. So let's think about what information is this function going to need. At the exact point in time when we call on the instructions in this function, I know we haven't built the instructions yet, but at the exact time that we call upon this instruction to be performed, what information will the function need? Can someone take a guess in chat? When we're about to call this function, what information will the function need in order to do its job? The number of matches. That's exactly right, Tristan. There'll be some way that you calculate how many connected matches are there. Now, I know in the real game, I think you play with yellow tiles and red tiles. I played a lot of Connect 4 as a kid. I think they're yellow and they're red. And the point is, if you're the yellow player, how many yellows are in a row? Gloria says, what is function DEF, please? DEF is a Python instruction that's used when you're about to create a function. It means I'm defining, DEF, defining a function. The name of the function is check when, and here's the information it needs when it does its job. Does that help, Gloria? No problem, Kimberly. Thanks a lot. Okay, good, excellent. So we need the number of matches. So let's put down here num matches. That's the information it's going to need, right? Now, let's write down the instructions that are going to happen when this function gets called. The way you do that when you're making a function is you do a colon at the end of this line, hit enter, and every instruction underneath this that is indented will only be part of this function. Well, we kind of know what to do. First, we have to check whether the num of matches is equal to 4. I'll let everybody get caught up. Notice what happens when you hit enter. It indents again. Because remember, this is the code block that will only be performed if, in fact, the value of this variable num matches is actually equal to 4. We're writing a code block. And we're going to do the same thing. Print, maybe I can spell that right. Yay! You win. I'm changing it up a little bit to have fun. And then hit enter. Watch this. This is important. Only go back to the same level as the if instruction. And then we know the rest as well. You can see it up above. We're going to have the otherwise. Else, do the colon. When we hit enter, it indents for us. And we're going to print no win, keep playing. Like that. Now, this is our function. We built this function. I'm going to let everybody get caught up for a second, and then I want to discuss something that's critical for you not to want to bang your head against the wall when you're trying to learn to code. So I'm going to give everybody a minute to get caught up, and I'm going to cover something super important. So I'm going to ask a specific question. Don't run the code yet. Just wait a moment, okay? But when we run this code, what's the last thing that will be printed over on the right-hand side? What's the last line that we printed over on the right-hand side? Take a guess in chat. What do you think the very last line of code is that will be printed over on the right-hand side? Oh, Nick, I see what you mean. Not the number line. I mean, what in terms of what it says over on the right, what's the last line of text that we printed on the right-hand side? What's it going to say on the right-hand side? Although you're correct, by the way, Nick. No win, keep playing. Right down here. Now, that's wrong. If any of you thought, and by the way, don't feel bad about thinking this. There's a very important concept that we're about to cover. And without knowing it, you might think that we're going to print no win, keep playing over on the right-hand side. Carmen asks, what does colon mean in Python? It means the lines that follow underneath this are to be part of a function or code block. If they're indented lines under this belong to this line. Look here. Indented lines below line 7 belong to line 7. And since line 8 is indented, it belongs to line 7. Line 9 is not indented. It doesn't belong to line 7. That's what a colon means. It means what follows below, if indented, is a code block. Does that make sense, Carmen? All right, so let's cover this. I'll tell you why it would make sense for no win, keep playing, to be the last thing that happens over on the right-hand side. And listen to this, it's so critically important. The only way you would think that the last thing we're going to print is no win, keep playing, is if you think that we're actually going to perform this code. Look what I have highlighted. If you think we're actually going to run that code, then yes, it would make sense that we print no win, keep playing. And this is bringing me to one of the most important concepts of the night. When you are defining one of these subprograms, again, in Python, they're called functions. When you're defining one, all you're actually defining is potential behavior. Nick, you're exactly right. They said it, but we aren't running the code, we're defining something. What you are defining is potential, possible behavior that could happen sometime in the future, but only if you ask it to happen. That's what a function definition is. We have defined, DEF, we've defined a function called check_when. We've clarified what information would be given to this function if it were ever used. And we have clarified what the instructions are that will be performed if we request that the function be performed. But we never ask for the function to be performed. The only instructions that are actually happening are these. Run the code and you'll see. We're only running these instructions. This is not an instruction to be performed. This is clarifying to your computer a function that could be performed in the future. It's a super critical thing. A function is just a definition for future behavior that could happen if you ask it to. Okay, fine, Eric. How do you ask it to happen? Well, let's go down to the very bottom, hit enter a couple of times, make sure you backspace so you're at the very beginning of the line. And the way you ask a function that you defined to be performed is just type out its name, check when, and in parentheses, give it the information it needs. Let's say the number of matches is 2. That's it. We're saying, hey, run the function that we defined earlier. We defined a function up here. Run it and give it this information. There's 2 matching connections. So now when we run this, it does say no win, keep playing. Because on line 18, we said, hey, actually run the function called check win. And we ran check win, and the information we passed in was the number 2. So now this variable num matches is equal to 2. And 2 most definitely doesn't equal 4. And so we're not going to do this code block. Instead, we're going to do this code block. Well, let's do it again. Go to the bottom and hit enter, and let's run check win. But let's say someone actually had 4 matches. Run this, and now it says, yay, you win. This is how functions work. I love the fact that I got to check whether or not there was a win twice with only 2 lines of code instead of 4 lines twice, which are 8 lines of code. It didn't take me 8 lines of code. It only took me 2. And there's another advantage. Let's say I want to change the message a little bit, and I want to say exclamation point here. I only have to change that in one place. And then every single time I use that code, that change is reflected. It makes it easier to change your program. Let's run it. And then I've got my exclamation point here. So we've covered the first instruction. We've covered variables and assigning a value to variables. We've covered making use of, changing the value of a variable. We've covered control and branching systems. And we've covered subprograms. You can define your own subprogram, and then you can call upon it anytime you want. Gloria says, can I practice coding Python without downloading any software? Absolutely. You can do it right here on this. You can use this link. It's yours to use over and over again. It's a free service provided by Trinket.io. We make it really easy so that people don't have to install a bunch of software. So the answer is yes, Gloria. All right, now let's get you all the code. Gracie, can you drop the link to the full code in here? And if you don't have it, let me drop it in right now to everyone. Bang, there it is. You got it twice. Code's so nice, we gave it to you twice. Here's what I want you to do. Click in there and do Control A to select all of it. Then do Control C to copy all of it. So copy all of this code. Then go back to your code editor. Erase everything you have. And then paste in the code. And after that, click Run. And I'm going to give you all a minute to play a game. See whether or not you win. I'm going to see if I can win. I won. Yes, I want to play again. Go, I was fast. I won again. Haha. This is a lot easier than when I played my sister. She was brutal. All right. So I'm going to give you all a second to play the game. Okay, good. So let's talk about this code a little bit. Now, again, we're not going to go through every single line of code here. That could take an hour or two, and you might want to fall asleep by the end of it. I do want to point out, though, that you can start to understand a lot of things here. I want to point out first, we didn't use comments, but you see these green lines, they all begin with a hash symbol. Those are comments, and comments are not instructions. They don't tell the computer to do anything. They're there for your benefit or for the benefit of other people trying to read through your program. And you can see these describe what's about to happen. Pretty nice, right? Now, the first thing we do is we import a big bunch of code that can help handle random numbers. I don't want to write code that generates random numbers. Turns out it's actually really hard, by the way, in a computer. And so there's a set of functions built by someone else years ago called random. And this set of functions, I can make my program get access to it with a special instruction called import. So that's what this line does. But now, look what we have. We are defining a function called initialize board. We are defining a function called print board. We're defining another function called drop piece. Another one called check win. Hey, that sounds familiar. Another function called computer move. And then another function called main. And finally, all we've done is declare functions or define functions. Finally, at the very bottom, we run this function called main. And along the way, you're seeing like if, you've seen that. This is a comparison operator. You know, a lot of this stuff should be kind of familiar to you, right? There's the print instruction, all this stuff. Some of it might not be familiar, but I just want to point out that you can probably understand this code a little better than you did at the beginning of this class. Here's another really important point. Can anyone tell me what is the first line of code that actually gets performed? The first line of code in this program where work gets done. And by the way, I changed the bottom of this a little bit. You might want to recopy the whole line of code here. Oh, I can't do that. I don't have edit access. I just changed the bottom to just say this. Look at my line 117. Not even going to get into why I did that. It's beyond the scope of this class. But can anyone tell me what's the first line of code that actually gets performed in this program? Someone said line 5. That was actually really, really smart. Except, Austin, think about this. Line 5 is inside a function called initialize board. So line 5 isn't going to actually be performed until we call this function initialize board. Where do we call this function? Well, it turns out we call that function right here on line 73. So clearly, line 5 isn't the first thing to happen because these things happen before it. Well, when do we call main? Right here. Remember when I said at the beginning of the class here that there are 5 fundamental elements of any computer program, and the first one is an entrance point, the first instruction to actually be performed. That's actually kind of important. Look at this program. This line doesn't do any work. It just makes some pre-made code available to us. This line of code, these lines of code right here, sorry, they don't do anything. We're just defining a function. That function isn't going to happen until we ask for it. And same thing here. We're defining a function. And we define functions, and we define functions, and we define functions, and we define functions. And finally, this is the first line of code that actually gets performed in the whole program. And so knowing that 5 things I talked about at the beginning of the program can really help you. It's pointless of me to just start at the top and start trying to understand what each of these things does because I don't know in what order these functions are called. I've got to keep on going down until I see the first point where we're not just defining functions, we're actually asking for one of them to be performed, and that's right here. And so I can go main. Oh, let me go up here to main function. It's right here. Oh, first make a variable rows, and we assign it a value 6. And we make a variable columns, and we assign it a value 7. And then there's some other stuff. We're not going to get into all this nerdy logic, but the point is, now we know where to start studying our program. All right, now let's do some Q&A here. All right, so I tried to pick up a lot of the questions while we were building the code, right? Anybody have any questions, stuff that I missed? We've taken a little bit longer than normal, so I won't do a lot of them, but I've got time for a question or two. Absolutely, Kimberly, you're welcome. Okay, all right, now let's move on. And by the way, stick around, we've got a free gift coming your way. A thing I want to point out is at the school, I'm going to talk about the school for a moment now, okay? We have 12 different online boot camps, and as you can see, they cover a wide range of technology subjects, including artificial intelligence, computer programming, website development, cybersecurity, design, data science, video game development, mobile app development. There's a lot of them. In fact, we have more certification programs than any other coding boot camp on earth. But what's even more important is how these programs are delivered. Our boot camps are self-paced, but they're also instructor supported. They're flexible. Students set their own study schedule, and you can enroll any day of the year. The content on them is very well-rounded and actually very in-depth. They're also affordable. As I said earlier, our boot camps are priced below the national average. A key thing about the boot camps is that every single one of these programs includes job placement training and job placement assistance. It's one thing to learn to be a developer. It's another to learn how to get hired and to get hired. And we teach both. But most importantly, these programs are designed for absolute beginners. No technology knowledge or experience is required, so you don't have to be a nerd to get through these programs. And who are these programs for? Anyone looking for a better career. Technology is a great industry to work in. I'll elaborate on that in a moment. We consistently land on every major best coding bootcamp list. Our average review rating across all major bootcamp review websites is 4.8 out of 5 stars, and that's based on student and graduate feedback. So we're very proud of that rating. This is what our graduates say about us. Now you might ask yourself, like, why work in technology? Couple highlights here, 3 highlights actually. Work-life balance is really, really good in the technology industry. You're not working 50, 60, 70, 80-hour weeks, okay? Also, remote work is very possible in tech. It's also a very creative industry and an industry that you can take personal pride in your work with. And finally, it's a stable industry. Don't listen to the media. It's a whole nother conversation we can have. I've been listening to people cry wolf about how programmers are, going to be out of a job. I've been listening to it since 1984. It's not going to happen. Technology is very stable. It pays well, and there's regular increases in pay if you apply yourself and keep learning. Now, that said, there are certain barriers to doing a boot camp. First one is money. It takes thousands of dollars to get through a boot camp. Now, we've tried to make that easier with multiple financing options, including a big upfront discount and lots of options for people who want to do monthly payments, no matter what your credit's seen. But the thing I want to stress here is that getting through a Tech Academy bootcamp is an investment in yourself. I've done full presentations on this, but you're giving yourself an unbelievably valuable set of skills that are paid or that get paid for really well on the open market. Another barrier to doing a boot camp is time. Frankly, there's just a lot of material to get through. I'm not going to lie, there's a lot to learn. Okay. Now, some boot camps attempt to handle this by doing their training in what's called a cohort. Everybody who starts their training starts on the same day, and they all move through the training at the exact same pace. Personally, I'm just being very upfront. I can't stand that training approach. That's the training approach they banged into my head in high school. It doesn't work. There's some things that I learn very fast, and there's some things where I'm like, I don't get this. We didn't want any of our students to ever experience that moment where the rest of the class moved beyond them. I hate that. We lose good people to technology because of that approach. We don't do that. Some boot camps even make you study on campus. You're required to go in. Well, our boot camps are self-paced, they're fully online, and you can choose your own study schedule. And part-time study schedules allowed, so you can study concurrently to holding down a job or even going to school. The final barrier to getting through a boot camp is this. You have to have some technical interest or ability. But if you've ever felt like maybe you're not that smart or technology just isn't right for you, I want to point out that that's not you, that's the materials. Some technology education materials are too hard, and they're too hard for a specific reason. Some educators assume too much existing knowledge on the part of the student. With our programs, you don't have to be a nerd. There's no tech background needed to enroll. Now, the last question I have for you is this. It's a couple questions. Are you working a dead-end job? And I don't mean that in a derogatory, mean way. I just mean this. When you look out to your future, 3 years down the line, 5 years, 10 years down the line, is the industry you're in capable of getting where you actually want to be? What is the maximum pay that you see people get in your industry? What does life look like? What does the schedule look like? If it's not what you actually want, then from that point of view, that's a dead-end job. Or maybe you're just flat out unemployed. Or maybe it's really important to you that you work from home or have some more flexibility. You want more time with your loved ones. Either way, and this isn't true for everyone here, and I understand that, but for some of you, is it time for a career change? And if it is, the Tech Academy is the solution. We're career change experts. That orange bridge you see there was chosen for a reason. We're trying to build the route into technology for everyone. And at this point, we have over a decade of experience in breaking people into tech. Most of our graduates make $30 an hour on average in their first job. If you do the math, that's $60,000 a year. We have over 1,000 graduates working in tech, from small businesses all the way to big technical positions at big companies like Nike or Facebook or Disney or Epic Games or Uber. So as a reminder, we have open enrollment. I encourage you to enroll. You can start anytime. Now, you stuck around this far. I appreciate you doing so. I have something very cool for you. We piloted this over the summer just to kind of see how it worked out. It worked out very well. We don't know when we're going to end it, but for now, if you enroll in September, there's a number of really cool gifts we're going to give you. The first one is, if you can figure out how to pay for your tuition fully up front, you're going to get 50% off of the price of your boot camp. That can save you thousands and thousands and thousands of dollars if you can figure that out. Also, if you're in America and you need a laptop to do your training, we'll ship you a refurbished laptop. It's yours to keep to get through your training. We only do that for people in America. Can't ship overseas, sorry. The other thing, and this is September enrollments only, there's no sales tax. No matter where you live, we will pay the sales tax for you. Depending upon where you are, that can be up to 8 to 10%. So that can save you, $500 to $1,000 depending upon what you're doing, okay? We'll also ship you physical copies of our coding books that will help you, okay? David, there are options related to that I don't have all the current answers for. You're going to want to fill out the form I show you here in a moment and talk to one of our enrollment specialists. They can tell you about how that works, okay? It's a good question. The answer was about federal Pell Grants. I don't know the current answer to that. So we're going to ship you physical copies of our books. More precisely, we have a phenomenal technology dictionary and coding books that you're going to want to have right next to you when you do your boot camp, and we'll ship them to you for free. We'll also give you a copy of the Tech Academy's Career Planning Guide. Now, this is the book that needed to exist. It's one thing to break into tech to get that first job, and I got to tell you, it feels wonderful. But then what? How do you navigate those first few years in your career? And we created a career planning guide that covers what to do in the first 6 months, the first 18 months, the first 36 months. It lays out an exact blueprint to set yourself up for a very successful long-term career. We put everything we've learned in decades into this book, and you get a free copy. You also get 3 months of free access to a special service we run, a subscription service called the Tech Academy Accelerator. I love this. I'm the one that delivers it. It's one of my favorite things to do. First of all, it gives you access to over 100 free educational videos and free courses. But most importantly, you have weekly workshops with me. And these are nothing held back workshops. All the voice and chat channels are open. Cameras are on. It's a conversation. And we do a deep dive and get our hands dirty and build things. And I answer every single question I possibly can along the way. And if I don't know what the answer is, I find out right then and there. They're a blast. They're meant to accelerate your career, and that's exactly what they do. So you get 3 months of free access to that. Finally, and this is huge, and this is the reason why we're not sure how long we're going to do this. If you enroll in September, you get unlimited job placement assistance. And that means exactly what it says. When you're done with the training part of your boot camp, and you move into the job placement portion of your boot camp, you can work with our job placement personnel for as long as it takes for you to get that first job. And they're really good at what they do. They're really good at what they do. Again, we've gotten over 1,000 people hired. We kind of know how to get that part of it done. But that just goes on for as long as it takes, whatever you need. So again, these are September only things. So again, stick around for your free gift. If you would like to know more, then grab this link. Gracie's going to put it into chat. And it says, do you help job placement in Canada too? Absolutely. We've helped people get hired in about 23 countries right now. We help people get hired everywhere. Because the fact is, the way to get hired in tech doesn't change anywhere. There's an exact pattern. There's an exact successful action or set of successful actions. So yes, we can help you get hired anywhere. So Gracie dropped that link in there. And if you click on that, you'll be taken to a very simple form. Go ahead and fill that out. Once you fill that out, it takes you through a series of steps all about the Tech Academy. There's videos and articles. They explain how the programs work, what the courses are in what order, why the courses are in that order, what's expected of you as a student, what's expected of us as a training provider. It's all laid out so you can make an informed decision. You can even use that to book a call with our admissions staff, okay? So go ahead and fill out the form. I'm going to pause a moment to take a sip of water and give you a chance to fill out that form if you want. And by the way, if you are taken to a login form instead of this contact form, it just means that you already have an account with us. And if you look at the bottom of the screen, you'll see what the default username and password is. All right. Let me tell you about our referral program. Since our graduates love us, referrals have been one of the top sources of enrollments for us for a long time. And so we have a commission payment, a 5% commission payment for all enrollments that happen from a referral. And it's not just for our graduates. You can do that too. In a moment, you're going to have a chance to email in for your free gift. And if you want to include any contact information for people that you think we should be talking to, do it. We'll keep track of that. And if they enroll, we're going to send you a check. Plain and simple, no questions asked. We mentioned books. The Tech Academy has 7 publications, including 3 Learn Coding Basics in Hours books, a coding book for kids and young adults, a technology basics dictionary, a project management handbook, and the book You Are Not Stupid, Computers and Technology Simplified, which is amazing. So it's enough about our books. But speaking of books, this is your free gift. We will send you a copy of our Learn Coding Basics in Hours with Python book. It goes way beyond what we can cover in these hour-and-a-half long classes. You can learn all the basics of coding with Python just from this book. We put a lot of work into this thing. So if you want your own copy, then grab that email address that Gracie just dropped into chat, books@learncodinganywhere.com, and send us off an email. Say I was in the class with Eric. He said I can get a copy of your Python book. Here's my name and my mailing address. Please send it off, and we will do so. We have people at the company who are tracked on how many free books they sent out each week. We want to send these out. So please, get your own copy. And leave that there for a moment for anybody who wants to fill it out and send us an email. And then we'll give you all the links to everything about us. All right, links. Gracie's going to drop this link into chat. It's for a service called Linktree. If you're not familiar with it, it's just a place to store all of your links in one location. It's kind of handy. And you'll find everything there. Links to our free educational YouTube videos, links to our books, our dictionary, links to upcoming meetups, because we'd love to see you at more of these free classes, links to all of our social media accounts. So please follow us on social media. And I just want to say thank you for taking your time. I mean, it's a Friday night. You'll be out there doing anything, and you took the time to invest in yourself and do a free coding class. And I really appreciate it. I hope it was helpful to you. Come to more of these, fill out that form that you see right there, and find out more about the school. And if it's a good fit, you're going to change your life. Tech is a really great industry to work in. And that's all I have. Thank you all so much. I'm going to stop sharing. And I think my camera's on. Yes, it is. Good. And I want to say thank you so much. Appreciate it. Have a great evening. And hopefully see you at the next time. Bye, all.